in Python and you've encountered the use of a TryAccept block. This is called exception handling. So why is exception handling important? In programming, you often make assumptions. Let's say you're going to ask a user to enter some URL. You're assuming that he will enter a URL that makes sense. Or let's say you're trying to open and read a file or hit a web page. You're assuming that the file or the web page exists. Now, what happens if they don't exist? What happens if these assumptions are not true? Your program will just stop executing. It will not know what to do. It will throw an exception. Handling these exceptions or telling the program what to do when it encounters such an exception, anticipating that it will happen and handling them is a very important part of programming in general. TryAccept finally. These are the keywords that you can use to do exception handling in Python. Let's go through what they mean one by one. Here's a block of code that you might write in a general way of things if you are trying to parse a URL. This is just the normal flow of the program. First, you'll prompt the user for a URL to enter. So that's why you are saying input, please enter the next URL to crawl. If the URL is blank, if the user enters a blank URL, we break out of whatever loop we are in. In this particular screen grab, we are not showing you the loop, but you could put in a while loop that will continue as long as the URL is not blank. Then you download the URL from the web using this URL-lib2 library. Whatever you have downloaded, you store it in a dictionary. There's nothing too fancy here. Here's the catch. You are assuming here that the user is going to enter in a valid URL. But what if the user entered a rubbish URL? Something like not a URL at .all. This will happen more often than you think. There might be a typo or a spelling error, and they might enter a URL that doesn't exist at all. There's no way this URL can be downloaded. So this particular line where you're telling the program to hit the URL and download it will throw an exception. Whenever a line of code throws an exception, the next part of the program following that line cannot be executed because the program will assume that whatever comes next depends on whatever has come till now. So since your program has stopped or thrown an exception, it cannot move on to the next line. Now, this could actually turn out to be pretty bad. What would happen if this exception is thrown and you wanted to do something really important after this particular line? Something that needs to be done regardless of whether the previous lines of code have been executed or not. So after the exception has been thrown, you still want a particular piece of code to be executed. How do you make sure this happens? What kind of examples could there be of such code? You might need to close a file or commit to a database. These are operations which are necessary, otherwise the file or database could get corrupted. So we need to find a way to detect if an exception has been thrown and take corrective action if that has happened. This is exactly what the TryAccept syntax will allow us to do. It allows us to check if an exception has been thrown, and if an exception has been thrown, it allows us to tell the program what to do next. Here is that URL passing code again, but this time with a TryAccept block. So put all the risky commands which might fail inside your try block. Then if any of those commands fail, tell the program what to do in the except block. So whatever backup action you need to take, you can put it in the except block. So it's also possible to catch specific types of errors. You can anticipate what types of errors your code might throw and have different backup actions for each of them. Let's take an example. So here is a piece of code that is trying to read a simple text file, and we have actually put in 3 except blocks here. Each of them is handling a specific type of error. So this is a way to do try with multiple excepts. sys.execinfo is a function that allows us to print a description of the last exception that was thrown by the program. So sys.execinfo will tell us what the error actually was. Is it an IO error, value error, or so on. e.error and e.stirError contain descriptive information about the exception caught here. Here we are calling the exception E. So e dot error number and e dot star error are attributes of the error e. Here we have told the program to do something different if the error is an IO error, and to do something different if the error is a value error. Raise is a way to throw an exception. Here you are explicitly telling the program throw an exception and ask the user what to do. If the exception was of the two types, IO error or value error, we knew how to handle them, so we did that in the program itself. But if it's a generic exception, which we are not expecting, we use raise to signal that we tried to handle the error but we failed, and the user needs to tell us how to handle the error or decide what to do next. Then we come to the finally syntax. So remember how we said that there might be some code that you want to make sure gets executed regardless of what exceptions might be thrown. Put this code inside the finally block. So let's say you had a really important operation that needed to be done, like committing to a database or closing a file. These kind of operations are necessary to make sure your databases and files don't get corrupted. Finally is a keyword that is used to mark the code that simply must always be executed, no matter whether an exception was thrown or not. So, after everything is done, the program will make sure that the code in the finally block is executed. This way, crucial cleanup actions always get done.